So yeah, to make it official then, welcome everybody. I guess the first one, Happy New Year, first session of the year for us. You know, I'm Paul Baylog, and then the other members of the steering committee who are partially absent. Sabri's not here, Brandon's not here, Siju, but we've got our newest member, Michael Madden. So he's been fortunate enough to he was able to get us hooked up with these speakers for tonight. And then thanks to the sponsors, GoBridge, they're picking up all the fees for the meetup, as well as the use of the Zoom account, all that good stuff. And then from Sabri, he's a CNCF ambassador. So he's hooked us up with some of the hosting fees. And actually, I need to adjust that because now that we're no longer using Crowdcast, I can boot them from that slide there, but we'll see. I mean, I guess there's only the few of us here, so I don't know. Bob, Jay, you guys have any questions? Guess we could probably skip it. Yeah, so anyway, that's really all it is. So anyway, Anthony, Dylan, thank you guys so much for, agreeing to do this. I know it's a reboot of one of your talks from GopherCon 2020. Yeah, no, definitely looking forward to it. I'm going to be enjoying my Lone Star beer. That's, I always wanted to be in Texas, but yeah, maybe now's not a good time.
Yeah, last week was not a good time to visit Texas.
Not at all. So I guess if you guys want to grab the screen.
Yeah, give me 1 second to get set up here.
All righty.
While he's getting set up, if anyone has any questions, comments, or heckling, definitely just feel free to unmute at any time and interject. We've got a smaller group, so we can make it more of a conversation than normal.
I don't have any heckling, but this is Jay. This is my second time coming to the Seattle meetup. I was at the one in the fall. It was actually my very first Go meetup ever.
Oh, nice.
I work for a payments company, and we actually purchased another company last year, and they did everything in Go. So that was really my first exposure to Go when we did the due diligence, and I was just blown away with it. Since then I've just dove headfirst into the whole Go culture, started converting everyone to Go, presented on Go to the execs, hiring all my SRE guys, to use Go. I come from a C background, and Go just hit me like I was born to work in Go. It's just so comfortable. I just love it.
Yeah.
So I was working, I'd been almost 16 years in C#.NET world. And I took a new job in a completely different industry. Everything was running on Linux instead of Windows. And this was a startup. I was the first hire. And I didn't want to write Python or Java and didn't want to go back to C++. And Go was the other option in 2016 for what's the best way to write network services in Go. And for Linux, to run on Linux machines. And it's been an adventure since.
Yeah, no, it's definitely a fun little language. Personally, I've been coding in Java for about 20 years at least. So it was kind of like I kind of wanted to contribute to some of these cloud native projects. And obviously they're all using Go for everything. So it's like, oh, okay, yeah, I jumped on like Linkerd and did some contributions to that, and then to the Viper project as well. But yeah, I enjoy it. I wish I could do more with it professionally. I mean, we do have some apps that I've actually created in Go, utility type things, command line function stuff. But yeah, no, it's really fun. I definitely consider myself still a beginner in it. Unfortunately, it's one of those things. Gotta immerse myself into it more.
Paul, it looks like I don't have permission to screen share.
No? Okay. Here, let's see. Let me stop share and all right.
Try again. Nope. Still
Still
says
not okay. Let's see. Advanced sharing. Who can share? All right. Try it now.
now he's happy.
There we go. All right.
All right.
Sweet.
We got the splash screen.
We got it. See them cute little gophers.
Yeah.
Yeah. Our PR department made that for us with the quarantine last year. It's like everybody's working from home in the road with the kids climbing on them. It's good times.
Okay, so I guess we'll get started. It is the same icon. It says GopherCon 2020, but we can pretend it says St. Louis Meetup.
Yeah, there we go.
Just use your imagination. And a presentation is called Untangling the Monorepo, moving to Go modules. So my name is Anthony Lee. I am located in Minneapolis, Minnesota. I've been writing Go since around 2016. And my first experience with it was at an ad tech startup where they had a Python service. And they kind of just dumped it on my desk and said, you have a month to learn Go and rewrite this. And then honestly, I thought it was a great way to learn. It was probably not very fun at the time, but got my feet not just wet, but just absolutely soaking. And I've loved it ever since. Worked in healthcare, logistics, ad tech, and now at CrowdStrike. And this was our fun fact for GopherCon, but my favorite beer of 2020 was Fair State's Mirror Universe.
Is that still the favorite?
I don't know. Open field for 2021. Still got a lot of months left.
Yeah. And so I'm Dylan Bourque. I have a BS in computer science. I'm located in Gonzales, Louisiana, which is just outside of Baton Rouge. I've been a professional developer since '98, and I've been working in Go since 2016 also. I've been in banking and healthcare for a long time. The startup I worked for was in fintech, and now I work in computer security for CrowdStrike. And my favorite beer is a local Louisiana beer from Parish Brewing called Sacred Islands.
Okay, so what is CrowdStrike? We are a cybersecurity company, and what we offer is a platform of endpoint protection products. Basically, what that means is we stop breaches. I think that's our corporate motto. I'm not 100% sure, but you may know us best from attributing the DNC attack in 2015, 2016 to Fancy Bear, the Russian state actor. And more recently, as of yesterday, our CEO was testifying around the SolarWinds breach that happened earlier this year. So we're very much in that realm of activity. We are the company that gives all those fun names to threat actors. So other companies may use like APT28, but we try to name them Fancy Bear, Cozy Bear. It's just a little more fun to talk about and easier to kind of identify. And what we do is we aggregate and analyze anything from consumer malware to state activity to prevent, detect, and block malicious behaviors.
In order to accomplish that goal, we process over 3 trillion events a week. And I think our latest numbers have that number closer to 4 trillion to populate a custom graph database of computer threats, ironically named Threat Graph, along with many other security services. To handle all that volume, we run pretty gargantuan clusters of Cassandra and Kafka to get all that information around. We've been using Go in production systems since 2015, and practically all of our backend services are written in Go. If any of that sounds cool, CrowdStrike is hiring. Despite the quarantine and everything else going on with the economy, we are looking for good engineers. We are remote first. I've been 100% remote since I started in 2019, and we have employees around the world. So if you're interested, please apply.
All right. So you've probably heard a lot of positive buzz about monorepos, and you probably heard just as much negative buzz around monorepos. These are all headlines just taken from Hacker News in the last few years or so, where someone's like, monorepos are the best thing ever. And then 2 months later, someone's like, they're terrible. Why would anyone ever do this? And in the comments, it's just a flame war. But there's a lot of opinions out there. So at CrowdStrike, we currently use a monorepo, and we'll be kind of digging into that in the next few slides. But with modules, so we're going to have a monorepo, and we wanted to re-examine that as we move forward with modules adoption. So for those that are kind of newer to Go, modules is the official dependency management system of Go, and honestly, it does not have monorepos in mind as like a first-class citizen of that dependency management. So we wanted to evaluate, where we were going from there to see if we want to continue to sort of support a monorepo or move towards a multi-repo. For us, a monorepo is more than just a bundle of packages with a single release. We have over 200 buildable production services in a single repository. So there's a lot of stuff going on there. And we'd have to handle multiple releasable modules out of a same Git repository. There are pure version control and developer experience claims around whether to use a monorepo or not, but for the purposes of this presentation, we'll be scoping it to Go and how that relates with modules.
So monorepos can definitely be convenient because all of your code is in one place. That's kind of the point. But objectively, they really don't play well with Go modules. For starters, one of the way you denote a release with Go modules is you create a Git tag that is formatted as a semantic version, 3 numbers split by dots with a V in front of it. So v1.0.0. If you have multiple modules in your repo, you have to go create specially formatted Git tags that include the version and the path to your module within your larger repo, which is not great. It's also a very common expectation with monorepos that all of your code is what you see is what you get. You change one package, you jump to another one, you build it, and it picks up your latest changes. That's kind of the point of having a monorepo with all your code in one place. With modules, though, changes in module A won't show up as available to any other module in your monorepo without explicit extra steps. So each module will build against the particular versions that are referenced in its go.mod file, which may or may not match the code that's in your current commit in your monorepo. To get around this, you have to create what the Go team calls a replace directive to tell the Go tooling when you see a reference to the module github.com XY, instead use the code that's on my machine at this relative path, which works well enough, but you have to manage that for all of your individual modules throughout your repo over time and shuffle them. It's a lot of extra work. On top of these mechanical complications, having a monorepo does have a tendency to reduce friction for questionable design decisions. Every project out there has a common utility package that started off as a good place to put shared code. Over time, more people added more things and coalesced dependencies from lots of different domains. You got string manipulation, IP parsing helpers, AWS SDK wrappers, and so on and so forth. You start off, when you end up with a package like this or a module like this, you think you're importing a string helper, but now you have dependencies on the S3 SDK, JWT parser, and Kubernetes, and nobody wants that. So part of the process of untangling the monorepo for us especially was to put code where it belongs. Take those kitchen sink packages, break them down into functional or business domains, and separate those out into individual modules rather than keep the one giant one. As Rob Pike likes to say, a little copying is better than a little dependency. So because they have code for a lot of different projects, monorepos can also be difficult to manage and build. There are tools out there like Bazel, but obviously they come with their own learning curve. Bazel can certainly build your monorepo, but it won't do it out of the box. You're going to have to go configure your own Bazel rules for your project to get everything to work. And the way I like to put it is, I'm not in the business of writing Bazel rules. I'm in the business of writing the software that I'm working on.
So our code base predates any kind of mature dependency management solutions for Go. For those of you that have been writing for a few years, you might remember Deplock or Glide. It predates even that. So we had opted, unfortunately, to vendor our entire Go path into the repo. So that means everything from what your $Go source would be was in a repository. We have nearly, well, not anymore, thankfully, but we had nearly 400 microservices and libraries, and that's not including all those vendor dependencies I just mentioned. So there are, hundreds and hundreds of different, what would be modules inside of one repository. One other quirk we had is our custom tooling makes assumptions about that Go environment and those Go paths that are not true for vanilla installations. So when we would onboard engineers, even if they had experience with Go, they'd still have to fiddle around with their shells and their Go configuration just to get things building, get things tested, get things running. And that's just kind of a pain in the butt. One of the more concerning ones is we had a module incompatible import paths. So back in 2015, we thought it'd be really cool if, instead of having to do like your VCS website / organization / project, which, looks verbose, we thought it'd be cool if we had like standard library looking imports. So we have CS/foo or like CS/string helper, those kinds of things. And it did look really nice, but unfortunately, those are completely incompatible with modules for any non-standard library. The first token of the import path must resemble a host name. So it has to have a period in it somewhere, even if it's not an actual host, but that's just kind of the rule that they had chosen. So all those just would break if we were to convert to modules right off the bat. And then as Dylan mentioned, we had a ton of kitchen sink packages and knotted dependencies. And we'll talk a little bit more about how these circular knotted dependencies were resolved and why they happened. Okay, so multi-repos, the alternative, right? It probably sounds weird that I'm even saying multi-repo because that's just how we refer to normal Git workflows and projects, right? It's just the default. And because it's a default, everyone kind of understands how to work in that workflow. Because downstream dependencies are locked to a specific version of modules, you can be more liberal with your changes. So you don't always have to be worrying about, I'm going to release a new change for this module. Am I going to break everything else? Because all the consumers of your code have already locked into an existing version that, presumably they've tested and built and verified is correct. So that's something that we wanted to move towards. We wanted to be able to encourage developer velocity in that respect. The flip side of the coin is if we were to split out all those 400 modules that I talked about, it seems like there'd be a lot of administrative overhead in just keeping track of them all, right? 400 individual repos sounds like a pain in the butt. But the nice thing is many projects and companies have already encountered this problem, right? It's not unique to have a ton of Git repositories out there. So it's easier to find tools that solve for these problems. Essentially every VCS vendor already has super repo level tooling available. And there are a ton of third-party tools as well. For example, in GitHub and Bitbucket, you can set access controls, merge strategies, and pull request options at a project or owner level already. So you can treat them as if they were a unit in terms of administrative policy. There are CLIs like my repos that can operate across multiple repositories if you just want to pull everything at once, just basic Git operations and things like that. And myself and the team wrote some simple tools to generate and maintain our particular boilerplate across all our repos. And another one of our team members wrote a pretty simple CI thing that just runs every night and updates dependencies for patches and minor upgrades that don't require human supervision. So yeah, I mean, it sounds like it's a lot of problems, and they are problems, but the nice thing is people have already built solutions for a lot of multi-repo problems, whereas as Dylan mentioned, monorepo problems are very unique, and there's not a lot of out-of-the-box solutions for those. So this is definitely more on the soft skills side, but soliciting buy-in was a big part of this project. So existing patterns in our monorepo were custom, but they were very methodical. In the end, it still required a significant amount of bespoke tooling and institutional knowledge to be able to even work within our monorepo, and that's something we wanted to reduce. As I mentioned previously, new hires who were accustomed to Go had to grapple with learning the custom workflows, which has meant onboarding just took longer. And you can't Google a custom workflow, right? It's all internal to your organization when you deviate from that. We also had engineers who were familiar with the existing workflow, where they had been working at CrowdStrike in 2015 when Go was immature, and they had only ever learned Go in the style of CrowdStrike, right? So bringing us back into the main line of idiomatic or community Go would have been disruptive to them, right? Because they had only ever grown up in the bubble, I guess. Because moving out their monorepo would fundamentally alter the developer experience for all parties involved, we had to arrive at a common vision and solicit buy-in, and that was just as important as all the technical details. We need to make sure that everyone felt like they were taken care of here. Honestly, this sounds like like some recruiter made me say this, but we really do have an open, receptive culture, and it makes it really easy to propose and socialize ideas. We have actually we're in it right now. We have a internal hackathon called Think Week, and this is actually where this project spawned out of. Dylan and I were kind of working on this and said, modules is here, we got to get going, and basically they gave us 2 weeks just to kind of come up with a proof of concept, pitch that, and then this is how we kind of got started with this. But yeah, so it's really important. Talk to all your developers, your managers, every single stakeholder that you can imagine, because it is a pretty monumental shift to properly adopt modules, even if with or without a monorepo.
Did you say that you guys are hiring?
Yeah, we are hiring.
Yes, we are.
So yeah, one of the guiding principles that we tried to have for this project was standard problems have standard solutions. And I kind of hinted at this earlier, but monorepos are custom and we have to build our own custom solutions, but multi-repos are just the default, and there's plenty of existing solutions out there. It's really simple. And as Dylan said, our priority is to write code, not code that manages code. Like I know some people like doing that, but I'd rather write the cybersecurity things and not the things to manage the code that does the cybersecurity things. We didn't want to work ourselves into clever corners and build and maintain a lot of custom development tools if off-the-shelf solutions were going to be sufficient. So decision time. These are kind of the questions we ended up asking to ourselves in the organization. How are our teams structured, and what are their goals, and how extensible are our existing CI/CD workflows? So dependency management and how you structure your code obviously matter tremendously to both of those two things. And I guess we haven't talked about CI/CD too much, but again, that's probably something very custom and unique to the projects you're working on or the company you're working with. So we didn't want to get too far into that. For CrowdStrike, it turns out multi-repo was a better fit. Again, we were rapidly hiring. I'm not saying this to brag or even talk about hiring, but it's just the fact that we were onboarding a tremendous amount of people, and shortening that onboarding runway was tremendous in just getting people productive. It increases independence and agility. Locking all those module versions and dependencies to a locked position at all is very helpful, so you don't have to be constantly tiptoeing around the code base wondering if a change you made in one repo or in one directory is going to affect the rest of the monorepo. And then we talked a little bit about Bazel. Just a bit more about that. That's just basically an enormous build system. It's extremely sophisticated, and it can do anything under God's green earth that you could imagine. But it's very complicated. We already had existing CI/CD expertise in Jenkins, so we kind of just retooled that and moved forward with that. And honestly, it's been working pretty great. Next slide.
So once we decided that breaking apart our monorepo was the right path and we got buy-in, obviously we need to be able to extract individual packages into modules in a way that wouldn't break any active work. We're a large company. We have almost 200 devs. At any given time, we have dozens of projects in flight. So any path that would have interrupted delivering those projects obviously would have been a non-starter. So the solution we ended up with was a combination of off-the-shelf tooling and a few custom pieces and a lot of good old-fashioned elbow grease. Unsurprisingly, go ahead. So unsurprisingly, first candidates for migrating to modules were the low-level packages that had the smallest number of dependencies. One of the tools that we found was this Go dependency analysis toolkit. It ends up installing a CLI that you run, and you pass it a Go package, and it generates these nice SVG graphs of your dependency tree. We ran that tool across a representative sample of several different services to generate the dependency graphs and then compare the outputs to select that initial set of modules that we would convert. For each one, the process was pretty straightforward. We used a custom tool that we wrote internally that we'll talk about a little later to carve off a package out of our monorepo, create a module from it, and push that into its new standalone Git repo. Once the test passed and we cleaned up whatever needed to be cleaned up, we vendored that module back into our monorepo, just like any other external dependency, and then updated all the internal references to use the new module path instead of our old custom CS/star path. Because our monorepo today is still built in GoPath mode, once we did that, all of our various libraries and services are using the module code instead. We repeated this process, basically working the way up the dependency graph. And the last step is a cleanup. Once everything was updated and everything was working again, we removed the original package so that only the module version exists at this point.
And funny little thing there, when we say remove the original package, we didn't hard delete it. What we did is we moved it into a quarantine folder, which was really funny when the pandemic started for like 5 minutes. But that's where they still are.
Yes. Ironic in hindsight.
Yeah. So another thing we wanted to make sure that we preserved was our Git history. So we had 5+ years of very well formatted, informative commit messages, obviously some better than others, and change history in our monorepo that we wanted to preserve. We didn't want to just, copy a directory with all of its, because all the Git commits span the entire monorepo. So there's a lot of noise in there. We want to make sure that we only want the commits that are relevant to the directories that we're pulling out. Luckily, there is a tool out there called Git filter repo, and it does exactly what I just described, I guess. It turns a subdirectory of an existing Git repository into its own standalone repo, and it'll kind of walk through all of the Git history and pull out, all the changes local to that directory. It also allows you, as the name suggests, kind of filter through and rewrite the history as needed, and seed a new repository with that project's, full annotation. So that was a very handy tool. There are supposed to be failure modes where it doesn't work and you can't rewrite the history, but I don't think we've encountered one yet. So honestly, highly recommend this one.
The only problem case we've run into is if you renamed a folder in your existing repo, because of the way Git stores history internally, it loses the history prior to the rename. So we did have a couple of places where a converted folder had no history, but it was because we renamed it before converting it.
Okay.
So as part of this giant refactor that we were doing anyway, it's not uncommon that companies have tech debt. Every code base has some old crusty corners that nobody likes to touch. doesn't follow coding standards because it was written 5 years ago. It works, but you build it and it has linter warnings that you just are conditioned to ignore. And it just, in general, it's bad. Nobody likes to mess with it, but everybody has it. That compounded with the fact that the general Go landscape and best practices have changed quite a bit over the last 5+ years since we originally started writing code. Since we were refactoring most of our things anyway, we were able to convince our development leads that it would be a good time to go pay down some of this tech debt and modernize some of this old code to use more current standard idioms to ease the learning curve for new hires. Another step above that is we got buy-in from the team at large to resolve lint issues as things were converted to modules, and to be able to apply a policy going forward that all projects need to lint cleanly, and we actually have that enforced by CI now. But an important point to this is don't make it harder. Don't include behavioral changes or cosmetic things that you don't like, indentation or names. Just take your existing code, convert it to be a module. There will be plenty of other changes going on that will be hard enough to manage. Don't make it harder on yourself.
Another one of these guiding principles that we've mentioned a few times is write shiny new tools to replace those crusty old tools to make code compatible with boring standard tools. So earlier we said we didn't want to write ourselves in a clever corner, and we ended up having to write custom tools, but it's only as a bridge to get us onto, mainline standard tools that, any relatively experienced dev would be able to know. It gave us an opportunity to kind of scratch that itch of I want to write something new, but also kind of put our outside of the box structure back into a box. So one of the tools that we did write to help with this process is called CSI. It was a crime scene investigator to check out the crime scene that was our Monorepo and kind of figure out what had happened and what to do with it. The nice thing about our Monorepo is everything was still systematic and structured, and every organization is going to be different. So as long as it is consistent, you can programmatically kind of tear it all apart. So on the screen is just the help. My mind is blanking. The help output of the CLI, and there are a few commands that you're probably going to want to implement if you're looking to do something similar to this. So we'll talk about a few of these commands later. One piece of advice if you're writing something like this is go directly to the AST libraries. Don't use grep or sed or anything weird like that. It's easy enough to pick up, and it's super comprehensive. So yeah.
So once we start down this path of converting things to be Go modules, one of the wrinkles with modules is a module is at its core a VCS URL, github.com, Bitbucket, whatever VCS providers are out there. But obviously you don't want to have all your developers hitting the internet every day for all their work. So the first step that we did during our proof of concept was to set up an internal Go modules proxy. We used Athens, which is an open source implementation of the Go modules proxy. It was very easy to configure and stand up. We use an S3 bucket as the backing store for the proxy itself. And some of the specific advantages of running your own local proxy, because it's not technically required, is your builds don't have to reach out to the internet because everything can come from your proxy. By running your own proxy, you have much stricter control over which dependencies can be made available. You can configure your proxy to reject specific modules that you don't want used in your system. So another wrinkle there is, and it doesn't apply to everyone, but potentially you don't necessarily want to expose your code to the public internet. If you don't run your own proxy, the Go tooling defaults to using Google's public module proxy. And every one of your builds is going to query Google's proxy for your own internal module paths. Maybe that's a problem for you, maybe it's not. As a security company, it was an issue for CrowdStrike that we didn't want to leak any internals about our code out into the public internet. And a little bit of a tangent from modules, but while we were working on this project, we also introduced our own internal vanity URL with a vanity proxy for all of our internal modules. It's a little bit fancy, but it lets you create a recognizable name for your own code and distribute that around through all your developers so everyone knows where your code is. A more technical advantage is it creates an indirection between your source code import paths and the actual VCS URL where your repo lives. As an example, say today you're using Bitbucket and later you want to migrate to GitLab or GitHub. Without a vanity URL, you got to go update all of your source code to point to the new URL. It was very simple to set up. We essentially have an Nginx web server with a config that's very close to this example that we have right here. And it's running on a single Kubernetes pod and serving our entire development organization without a hiccup. So obviously, Go modules introduces some new configuration. You need to make sure that all your developers are using your modules proxy and have their environment set up correctly so that you're not leaking your modules out into the public internet. So the first step, and this has changed today with Go 1.16, but we did have some developers who had the Go 1.11 module environment variable set to off to disable modules completely. So we had to work with our infra team to make sure that modules wasn't disabled, that everyone was using our Go proxy and not hitting the public Go proxy that Google provides, and that they used the Go private environment variable to tell the Go tooling not to query proxies for our internal modules. That was a restriction that we also needed because all of our modules require specific logins. They're private repos internally, and the Go proxy and the public Go proxy, even more so, don't have the ability to log into our VCS. By using Go private, we can tell the Go tool to skip the module proxy and go directly to VCS and use the developer's credentials.
So what were the impacts at CrowdStrike? Either mono or multi-repo can work for your organization. We're not saying never use a monorepo or always use a multi-repo, but these are just a few of the impacts within our organization. The key takeaways were reducing complexity and increasing flexibility. So we reduced the tool chain needed to mostly just Git and standard Go operations. So allowed developers to spend more time developing and less time managing the source code and moving it around. Simpler module management is a big bonus too. You have one repo and you have one module. It makes sense, right? There's not a whole, you don't have to think about it at all. And having all of your dependencies wrapped up in a single go.mod file makes it really easy to see what your dependencies are. So the knot that we had before is because everything's within arm's reach. You'd never hesitate to add a new dependency on. So you had ridiculously simple services that had like 40 different dependencies on things they just had no business importing. So yeah, being able to see your dependencies in one place, I think is extremely valuable. With repos as a new atom of projects, you're able to more clearly define the boundaries of ownership across projects and teams as well. And concise dependency graphs make for more independent teams. You don't have to check in with this other team if, can we make this change? Will this build correctly? There's just a lot less crosstalk across teams and projects now. It did result, thankfully, in significantly quicker test and build times. Instead of having to, test the entire monorepo, you can just test individual components that were changed and its downstream components. And it also reduced the blast radius for potentially problematic changes. So if you did introduce a bug into the monorepo, it could potentially affect the entire monorepo, but with an individual module breaking, that doesn't even matter. Only that module is broken because all the other modules are still pinned at previous versions of the module and can be, rolled back if even necessary. So yeah, a broken build doesn't block 200 plus other services or anything like that.
So obviously, this was a huge project and we learned lots of things going on. Unsurprisingly, there are no magic silver bullets that are going to solve all your problems. The first one is either properly vendor or fork your external dependencies. One of our big challenges was around vendor third-party dependencies that had been updated within our monorepo for specific things that CrowdStrike needed. That makes it very difficult to migrate forward because the security fixes in the upstream collide with your edits, and it becomes a development task to maintain your fork essentially of the repo and keep it in sync with the actual dependency. Second one is don't create utils and common kitchen sink packages. They grow tentacles, they end up connecting themselves to your entire code base, and it makes managing code very, very hard to do. Another one is be conscientious about breaking changes in your APIs. One of the new things with Go modules is called semantic import versioning, where for modules that have a version of 2 or higher, you have to append the major version at the end of all your import path. So if you have your module github.com foo and you make a breaking change, you have to go update your module to version 2 with a git tag, but also append /v2 to the end of your module name and all the import paths that consume your module. So with Go modules, a breaking change and a major version bump is a big deal. So you need to pay attention to that. And the last one is be prepared to do a lot of hands-on code wrangling. If you have a non-trivial project, you're going to have a lot of code, and it's going to have a lot of fun edge cases that will only apply to you. Be prepared to do some code digging, and if you're already good at it, it's a great advantage.
Some things I personally learned, I guess, were a lot of Git internals, which I've probably forgotten already, but it was very interesting at the time figuring out how like Git actually works beneath just the basic command line commands you give it. Learned a lot about AST parsing, and honestly, the big takeaway is probably around building consensus and those soft skills around bringing your project forward like this.
One that I figured out indirectly is that Git grep is much more efficient at searching source code than the find CLI. Git grep looks directly through your repo index rather than walking the file system. Another one is that if you Google search something, it may just not work for you. An example is the pre-installed sed tool on Mac behaves very differently than the GNU sed that all the people on Google and Stack Overflow post their examples from.
I think we had like 9 engineers on a single Zoom call trying to figure out why SED wasn't working, and it must have been the biggest waste of man hours. But
It was
was
the
hilarious.
most expensive Zoom call of all time.
yeah, I think we had like 2 principal engineers on there because they were just so invested in it. But yeah, it was great.
I can relate to that pain. It's like,
So that's it. We thanks for listening. Again, if all this sounds cool and cybersecurity sounds interesting, we're definitely hiring.
all right.
And we have a couple of links here. All the pictures in the slideshows came from the Google Arts and Culture project. The Goda tool is there. We used Athens for our module proxy. The PacMod tool is a command line that can, given a directory of Go source code, will create the zip file and the correct files so that you can upload them into your module proxy. Go ModGuard, I think Anthony mentioned earlier, is a tool that another one of our coworkers wrote that actually integrates into the Golang CI lint tool, that we can set up gates for allowed and explicitly disallowed modules and versions to kind of put some boundaries around the Wild West of adding references to anything out in the wild. And the My Repos tool is the one I use to manage all of those separate. I think I counted today, we're at 107 module repos. So we're well into our monorepo to modules conversion. But with the My Repos tool, I can run mr update. Mr is the command line that installs, and it will essentially do a git fetch on all 107 repos. It's very convenient to have that. And we can chat, or we can do whatever from here. That's the end of the presentation.
All right. I see Jay's got his hand up there in the chat.
Can I go ahead?
Yep.
So very great presentation. Thanks, guys. I loved it. Just curious, do you think that the consensus part was harder than the actual technical challenges, at least that, you know, in your organization?
It's kind of hard to compare, but I can share that there were 2 previous efforts to move to modules, and we just never got enough momentum to actually do it. And this is actually the 3rd time that it's been presented to the stakeholders in our organization. So, but it was also just very difficult technically. So, yeah, just 2 very different types of problems.
Yeah,
because modules had been around since what, Dylan, like 2018 or something, at least in a pre-release. And
yeah, the
and
consensus was getting buy-in was definitely important around breaking the monorepo up and changing the process.
Yeah,
and we, with nearly 200 developers in dozens of teams, it was a big deal to not break people's day-to-day work.
Understood. Thank you so much.
Oh, that's cool. I know. Yeah, I had to write a note on that. The Athens, the proxy, because that's kind of cool. I know for us, you know, at work we use actually Artifactory. It's a JFrog product because you know we use for like Java dependencies and things like that. You know, cache Maven Central type artifacts and that. And I know they also do Go. The Go modules as well. So, but yeah, I don't know. I'm gonna have to check that out though.
Well, Athens is a much smaller footprint than Artifactory.
Yeah.
I think it took us like, I don't know, like 2 hours to get Athens running, right? It was incredibly easy to stand up and configure.
It took more time to get ProdSec to approve using an S3 bucket than it did get Athens running.
Wow.
Oh, too funny. Yeah.
I had a question. as you split up the monorepo into smaller repos, did you find like the build times for the project increased, or were they less resilient, or did all that orchestration add more overhead, or how did it impact that as you broke
So
things up?
individual builds are like astronomically better. Our full monorepo build is typically 35 to 40 minutes. The individual module builds are sometimes 20 seconds, usually a minute and a half, 2 minutes, counting the get clone stage and reporting everything. But the overall build ends up being accrued. So you change a module, that one takes 2-3 minutes to build and tag. Then you build the next module and it kind of cascades in. We still have the monorepo and we're vendoring the modules back in. So at the end of the pipeline, we still have that 35 to 40 minute monorepo build for the rest of the system that hasn't been converted to modules yet. But the modules themselves literally build in a minute for most of them.
Oh, wow, that's cool.
Definitely. Let's see. Did we have any other questions in the chat? It was the one I know just about getting the slides.
Yeah, I think I'll save this as a PDF and then I'll send it to Mike and he can forward it on.
Yeah, that's fine.
Yeah, because I typically throw all this stuff into a Git repository as well, and then I'll have the slides there and everything, so everybody can reference it if they want. So cool. All right. Well, let me. I guess
I had one more question, if nobody else does. Do you see any advantage, like if you're doing open source development or just personal development, of running a Go proxy yourself? See any advantage of that?
I actually know someone who does it more for if they need to be somewhere without internet access.
Right, makes sense.
To have a local, effectively a local proxy with all the modules stored. And it works. It's really not that difficult to set up. You can run Athens yourself, point it at a directory if you have the space, and it'll download the module once from the internet, and then you have it locally after that.
Right.
So if you're the type of person that likes to tinker, it can definitely help, but it's an extra step.
And just to clarify a little bit more, normal modules will cache those dependencies too on your local machine. So if you're looking just for a speed up, it's not going to really do anything.
Right. So those would generally be like in your package directory in your Go path, right?
Yes.
Yeah.
Yes,
So
yeah.
there's multi levels of caching.
Right.
I had another question. It sounds like, with your very tight security concerns, someone, a new, someone who's just, been hired and comes on board, they might expect to just be able to, grab any package available and start working with it. Do you guys have some sort of, a review or rules around what packages are even allowed to be used?
Yeah, so maybe Dylan, you could speak more about this, but we have 80 groups that gate certain repositories or groups of repositories. So it's kind of all integrated within our broader internal authorization.
Yeah, and then as far as which external dependencies, it's kind of informal within the engineering org, but we like we mentioned, we do have effectively a linter that runs on all the module builds, and it will trip if there's a reference to a module that hasn't been vetted and approved. But the process is pretty informal. It's not a very academic, we're going to sit in judgment and decide whether or not it's okay. It's more, we don't want to end up with 7 different CLI helper packages and 4 different Redis libraries, and like, we already have this. Why do we what's the advantage of having another one, kind of an informal discussion. And then if it makes sense, we add it to the allow list and we pull it in.
So would you recommend to a newbie to go take a look at the current repositories and see what's already in use, before?
Yes, in general, it's A, what do you need this for? And then B, we already have something else that is mostly overlapping. Go look at it here.
Cool. Thanks, guys.
I had one more question. Can you detail like the advantages of using like Go's built-in AST versus like common Unix utilities like sed and grep? Why would you want to use the parsers that are built into Go versus the common Unix utilities?
I don't know if I should write down notes, but honestly, it's easier just to write a CLI completely in Go than try to integrate all those Linux commands. Yeah, and running them in a command exec or something like that. So yeah,
the walking the compiled AST is definitely easier than, especially if you're looking to update things.
Oh yeah, that's the other thing. You can just tell like rewrite all the import paths, and then you can also just tell it to format. You can tell it to go format and everything too. So yeah.
Yeah, rewriting import paths is a big deal. It's definitely easier to do that by walking the AST and then saving the file, saving it afterwards, than it is to go learn the right grep sed voodoo to go pattern the strings and replace substrings within the groups and things. It's definitely easier to just use the AST.
Okay.
I think we did try just like, like VS Code, find and replace all, and the laptop just started on fire or something.
Control shift.
Definitely don't do that. That doesn't work, guys. Yeah.
That's a bad plan. Don't do that.
Oh, too funny. All right. I don't know. We got any other questions from anyone? Comments? All right. Let's see. Let me switch back over here. All right. All right. Well, I guess we'll go ahead and close it up then. Yeah, for anybody that's left, we got a couple still here. Yeah, please be sure to let us know how we're doing. If there's any kind of topics that anybody wants to hear about, or if there's any kind of speakers that we want to try to hunt down, feel free to let us know. I've got it on here too. Open an issue at our GitHub. I think I have issues turned on. I hope so. But anyway, if not, I will do that. So let's see. Next here. Yeah, social distancing. Just feel free to join into the St. Louis Tech Slack. We're in the Go channel. And then just more generally, the Gopher Slack. I think I saw you active in there, Dylan, actually the other day.
Very active in the Gopher Slack.
All right. Yeah. So definitely get into that stuff. Yeah. Now this one, the giveaways. Now, normally we do have some giveaways, but since Brandon didn't show up, I have no idea how many JetBrains licenses that we do have. So I know that he has mentioned something that JetBrains is not too happy with this right now. I guess we've given out some licenses in the past and they weren't fulfilled. They weren't, used up. So they're like, hey, if you want to keep getting them, you got to use them, kind of like a budget, right? So anyway, so I'm sorry, we got to skip the giveaways for today. Yeah. But anyway, so next month, again, this was our first one coming back in the new year. Next month, we're going to have Angelica Hill. She's going to be doing another reboot from GopherCon, but no, it's all good stuff. And then she will be speaking about, anyone can be a gopher. this is one that I really want to get my daughter to attend. So I don't know. I keep telling her, you know, come on, let's code. So, but I don't know. Maybe one of these days. So anyway, Dylan, Anthony, thank you guys so much for
Thank you.
attending with us and speaking to us. It's really, really appreciated.
No problem. Thanks
you
for
know,
having us.
yeah. Hey, maybe we can have you guys some other time again. You know.
The wonders of
knows?
modern technology.
Yeah.
I just
Exactly.
attended a St. Louis meetup from South Louisiana.
Exactly.
Yeah.
Exactly. Well, you know. That's
Did
one
one
good
in
thing
Boston
about the pandemic, right?
Right.
Kind of more regional nowadays. But yeah, and then who knows? Maybe we'll see at you know, an internal CrowdStrike meeting. You know, because I hear you guys are hiring. So
Yeah.
Did we mention we're hiring?
I'm definitely hiring.
And my employer too, while we're at it, yeah, we're hiring as well. Cloud engineers. You don't get to do as much Go, but you know, it's still some fun stuff.
That was a subtle nudge from our recruiting department when we were doing the GopherCon presentation that, hey, by the way, we do this conference thing as a recruiting tool.
Yeah,
So you need to mention that we're hiring.
exactly. Yeah, well, you should have told them that you know, they needed to provide some T-shirts and you know, maybe some squishy balls or something for you know, marketing and such. So
We got some good swag.
exactly, everybody loves swag. So all right, well, I see Charles now is joining us here, and then just in time for the goodbyes. So so yeah, so unfortunately the live stream didn't work, but we should have the recording, so I will be posting that up to YouTube. And then yeah, Dylan, I guess we'll get the slides from you via Michael, and then I will get those into our GitHub repository. So anyway, that's all we got. That's the end. So thank you again, and
Yeah, thanks a lot.
everybody yeah, stay safe and healthy, and then hopefully we'll get back to in person one of these days. So
Thanks, everyone. I
Thank you.
enjoyed it.
Bye.
Thanks
all.
a lot.
yeah. All right,
Bye.
bye.